Let's read this problem. A strange name game. This there are two players, Elias and Bob, and they are playing a variant of name game. And basically, there are n towers, and ith tower having AI rings, and you can basically select a tower, and then you can remove a positive digit d, which appears in the decimal representation of the current a decimal representation of AI. For example, like if AI is 5028, then he can select 5, 2, or 8, and the game ends when there are no moves. And basically, there are q queries, and we have to answer that. Uh, First query type is L to R, and we have to count the number of subsequences in L to R that will result in Alice winning. And the second type of query is basically we have to update the current element. So how to do this? First, let me tell you one thing. First, let's look at one array, like simple array. Here, game. This is related to Grundy theorem, the number CP algorithm. If you go here, there is a theorem. You can directly remember it, which say that uh, yes. Here look, if you are at a state V, current state V of a two-player game, and you can reach these states Vi with the states reachable from it, then then the Grundy value for the current state is basically the max of all the Grundy value of the reachable states. For example, if you are currently at 25, then basically you can reach at index 20 by choosing 5, or you can reach to 23. So if you know the Grundy value of 20 and 23, then you can calculate the Grundy value of 25 also, which is basically equals to max of Grundy value of 20 and Grundy value of 23. Now, how, like, what is the use of this Grundy value? So if the Grundy value of some number is some state, uh, wait, so first we are given an array a1, a2, something like that. What we will do, we will calculate the Grundy value of all these a1, a2, and a3 for all the elements of array. Now, how, and the base case for this is basically Grundy value of 0 is 0. Grundy value of 0 is 0. Basically, this is a losing state. If you all the, if the current state is like current value is 0, then you can't go to any other state and you will lose. So the Grundy value of 0 is 0, and so we can use dp to calculate this. For the example, g of 1 is basically 1. You can select 1 and then you can win. So now the theorem says that if you know the Grundy value of all the numbers, and if you are given the array, then this, if the XOR of the Grundy value of all the elements is non-zero, then you will definitely win there is an optimal strategy by which you will win. If the XOR is 0, then you can't win. If the both players play optimally. So now for this you go through this uh, uh, you go through CP algorithm and you read some of that, or just remember it will be very useful. Like if you are at current state and you can go to like different states, then just calculate the Grandi value of the different states and use that Grandi value to calculate the Grandi value of current state. And finally take the XOR, and if the XOR equals to 0, then you will lose, and otherwise you will win. So the problem reduces to, like, we know how to solve for one array, but we have to solve for all the subsequences of an array. So one observation is that, first let's see the code for this one, how to calculate the Grandi value of this number. uh, this one. So you have to, as the maximum value of n is, don't look at this route right now, and this one also, yeah, this vector, the maximum value of ai is basically 2e5, and I am storing the Grandi value of the number in this array gr, and I am computing it here basically. You can ignore this one, this code. So here, yeah, just look at this. I am going through all. I first converted the current number to string, and for all the characters in this string I extracted the digit. If it is not equal to 0, then I can move to that state. So I basically stored in v1, I stored all the states from where, which is reachable from I, and finally I take it the max for all the states in v1, and I calculated the Grandi value of current value of I. So yeah, this is relatively simple. Now uh, one observation is that if you find the maximum Grandi value for all element 1 to 2e5, then you will find that it is only 6, I mean 0 to 6. So this is kind of, we can use this uh, to solve our problem. Like we have only value ranging from 0 to 6, and like we are given an array where all the elements are from 0 to 6, and we have to count the number of, basically we have, what we have to count, we have to count the number of subsequences. Let's suppose we are considering this subarray, then we have to count the number of subarray whose XOR is not equals to 0. Now how to approach this, how to do this? For that, uh, what we can do is, as we are only interested in XOR, now if you consider, like if I give you that in range L to R, there is, I give you the number of times 0 occurs, number of times 1 occurs, number of times 2 occur, number of times 3 occur, and so on, and number of times 6 occur. Then can you calculate the XOR of this uh, this range L to R? Yeah, you can basically, if the number is x, if the number of 1 is odd, then you will take 1 basically, and if the number is even, then you will not take it. Suppose this is 2, and suppose this is 3, and suppose this is 4, and this is 6, and like ignore the middle, like, then the XOR is basically only 3. XOR of this L2R range is 3. Now what we can do is we consider the subarray L2R, and somehow we know this number that in range L2R we have the count of 0, count of 1, and count of 2, 3, 4, 5, and 6 for all the number up to 6. We know the count. Now we have to do for all the subsequences. Now how can we create the subsequences from this data? Can we create this? Yeah, we can like basically iterate over all the possible combination. We can like take, if there is 2, then we can take any times, like we can take less than equals to 2 times 0, less than equals to 3 times 1. So we can create the all the subsequences. For that, what we will do, we will iterate from 0 to 2 raised to power 7 minus 1, and let's suppose the I am at currently I am at mask at current mask m. Then if see the representation, binary representation of m, even if it is like 1 0 0 1 0 1, something like that, then what I will do, if it is 1, then I will go to index 0 and I will pick the odd occurrence of this odd times. If it is 0, then I will pick even times. This 0 represent that I am this 0 represent that uh, this 0 refers to the index 1, like see from this side only. So this 0 represent that I am taking 1 even number of times, even number of times. So the so finally what will be the zor? Zor will be uh, we have taken the number from 0 to 6 which is taken odd times. So in this case 0, and this is 2 3 4, and this is 5. One zor of 1 2 and 5. And what about the number of choices? If we have like if we have here, for out of 2 I can take either 2c1, 2c0. Basically I am taking let's read from uh, I can take basically one occurrence 2c1. I can't take more than that. For here I can take 2c, I have to take even times, so 2c0 plus 2c1, 2c2, because I have to take even times, and similarly 2c0 plus 2c2. No, here 3. I have 3 choices. Here 4c2 plus 4c4 and so on, and we have to take the sum. These are all possible combinations, all possible choices I can take, and take the sum of this. If you see that the sum of this is basically equals to 2 raised to power n minus 1, 2 raised to power n, the current 3 minus 1, 3 minus 1, the like 4, which is basically equal 3c0 is 1 and 3c2 is 3, so 3 plus 1 is 4. So if 1 occurs x time, then the total number of choices is basically 2 raised to power x minus 1. Now the question simplifies to basically, if we know the count for all 0 1 2 up to 6, then we can, what we can do, we can iterate from 0 to 2 raised to power 7 minus 1, and we take the current mass and we calculate the zor of all the numbers whose bit is 1. And if the zor is not equals to 0, then we can take that combination. We can take this, we can consider this mask. Like if it is 0, then there is no, we can't win using this mask. And for the calculation of this, we can basically sum up all the 2 raised to x minus 20, because I have here two C1 choices. And 1 minute. Oh no, it like we have to multiply this. We have to multiply all the choices from here and here, here, and all that. Now the question is how to calculate this one. How to calculate the count of 0, count of 1, count of 2 in L2R. This is relatively simpler, like if you know the basic segmentary, or like you know the black box, how to use this. So we can create 7 segmentary, and if it is 0, then I will mark there 1. If it is like consider, I will build 7 segmentary, and for number x, they consider x can be 0 to 6. So what I will do, if the current element is x, then I will mark 1. If current element is not x, then I will mark 0, and I will create an array of length n. And for counting L to R, what I will do, I will take the sum from L to R only, and that will be the count of x in subarray L to R. Why we need segmentary? Why we can't use prefix sum? Because we have to, we are given an update. For update, we have to use segmentary. So if we are given, we have to do an update, then what we will do, we will basically like update the current index. Like if the current element is changed to x, then we will go to that index and mark here 1. And if, and we have to subtract the that element also. Like if y move to, y is changed to x, then we have to like subtract 1, like we have to subtract 1 from that index also in y sub y array. So yeah, that's fine. Let's look at the solution. Let's look at the code. Let's clean this first. Here, this is a segmentary which calcul which basically calculate the, this is some segmentary. It will add, it will give the L to R sum in log n complexity, and here, and we have a point update here, and this is a binary exponentiation code. And let's see. So we first computed the Grundy values, and then we taken the input vector, and then the maximum value which can be 7. Like maximum number is basically 7, 0 to 6, so the total count is 7. We created 7 segmentary, and for each one, what I am initializing the segmentary. And yeah, uh, I for each, I am iterating out the vector, and I take the current value is g. So I am going to the segmentary corresponding to g and updating the index I with 1. And for query, if that it is type of type 2, I am basically using 0 indexing. So what we will do, I will go to the current value, current, like the current segmentary, the the segmentary corresponding to the current value of current element, and I am updating that index like with -1, like subtracting -1, and updating the current value v of I with x, and again going to the adding 1 to that correct index. Now for L to R, we have to count the number of subsequences. So this count store the number of times index I occurs in L to R. So this is basically count of I is basically go to that segmentary, and query from L to R, and it will store. Now for I will move from 0 to 2 raised to power 7 minus 1, and I will calculate the XOR and number of ways in boolean. So if the current bit is 0, current bit is on, like it is 1, then I will take the XOR. And can I take an odd occurrence of that element is as it also matters. Like if I am taking odd occurrence, then the count of j must be equals to 0. Otherwise we can't able to make this I make this mask right now. So if the count of j equals to 0, then we are not able to select an odd occurrence. So if count of j, then I am multiplying the number of ways with 2 raised to count of j minus 1. And if XOR is not equals to 0, and at the same time we are able to select current mask, then I am adding the answer with the number of ways, taking modulo and printing the answer. Thank you.